Have you ever stopped to think about the most complex, most sophisticated network in the known universe? It's not the internet. It's not some global logistics network. Nope. It's the command center that's running your entire life, right this very second. We're talking about your nervous system. Just think about it. Right now, there's a biological supercomputer inside you that is processing millions of data points. It's controlling your breath, your heartbeat, that little muscle twitch you might get in your eye, and it's generating every single thought, every feeling you have. And the crazy part? It never ever takes a day off. So to make sense of this absolutely incredible system, it helps to think of it like a giant company. And this company has two main divisions. You've got a central headquarters and then a massive network of messengers out in the field. Okay, so first up, you've got the central nervous system, or the CNS for short. This is the command center. We're talking the brain and the spinal cord. Think of it as the CEO, making all the big, important decisions. Then you have the peripheral nervous system, the PNS. These are all the nerves branching out from the spine. They're like the workers on the ground, carrying messages from the CEO out to the rest of the body, and just as importantly, bringing feedback right back to the top. But to really understand how these messages get sent, we have to zoom in, way in. We're going to go from this big picture view of the whole system down to its most fundamental, its most microscopic building block. And here it is, the neuron. This single, highly specialized cell is basically the hero of our story. Its entire unique shape is perfectly designed for one thing and one thing only: communication. And get this, you have around 86 billion of them, all working together inside you right now. So let's follow a signal on its journey, shall we? It all starts at the dendrites, these little tree-like branches that catch an incoming message. From there, the signal zips over to the soma, which is the cell body. The soma's job is to decide, hey, is this message important enough to pass on? If the answer is yes, then bam, an electrical charge blasts down this long tail called the axon. At the very end of the line, that electrical jolt triggers a release of chemicals across a tiny, tiny gap called the synapse, passing the message to the next cell. So what's the secret to the nervous system's incredible speed? Well, a lot of these axons are coated in a fatty layer called the myelin sheath. The best way to think about it is like the rubber insulation on an electrical cord. It keeps the signal from fizzling out and allows it to travel at an absolutely astonishing 250 miles per hour. So here is the really crucial part. It's a dual system. The signal traveling down the neuron is pure electricity, but to jump that gap to the next neuron, it has to convert into a chemical message using things called neurotransmitters. It's this constant, lightning-fast switch from electrical to chemical and back again that powers the whole shebang. Okay, let's zoom back out and head back to the headquarters of this whole operation, the central nervous system. It's time to meet the key players who are running the show. You know, the brain is just a masterpiece of organization. You've got the cerebrum, that big folded part on top. That's for all your high-level thinking, your memories, your personality. Then, tucked away in the back is the cerebellum. It handles balance and coordination. It's the reason you can walk without even thinking about it. And finally, the brainstem. That's your body's autopilot, taking care of essential stuff like breathing and your heartbeat. And it does all this using 20% of your body's oxygen and calories, even though it's only about 2% of your body weight. Incredible. And that brings us to the spinal cord. It's so much more than just a bundle of nerves. It's a heavily protected, two-way superhighway for information. All the sensory info from your body travels up this highway to the brain to get processed, and all the motor commands from the brain travel down the highway to the body to make you move. So if we leave that central superhighway, we now enter this vast, sprawling network of the peripheral nervous system. This is the part that connects the command center to every single nook and cranny of your body. Now, functionally, the PNS is broken down into two main departments. You've got the somatic system. This is everything you control on purpose, like when you consciously decide to pick up a cup of coffee or wave your hand. Then you have the autonomic system. This is the total opposite. It handles all the involuntary stuff you never have to think about, like your digestion, your breathing, or your heart rate. Now, within that automatic system, there's this really fascinating push and pull dynamic going on. It's made up of two rival divisions that are constantly working against each other to keep your body in a state of perfect balance. It's a concept called homeostasis. On one side, you have the sympathetic division. You've probably heard of this as your fight or flight response. This is what revs you up for action. Your heart starts pounding, your pupils dilate, you are ready for danger. Its rival is the parasympathetic division, often called the rest and digest mode. Its job is to calm everything down, slow your heart rate, and conserve energy. Your body is in this constant dance between these two, adjusting on the fly to whatever life throws at it. Okay, so we've seen how the whole system is structured, but how does this all come together in a split-second, real-world scenario? Well, let's look at an action that happens literally faster than you can think about it. The reflex. So imagine you accidentally touch a hot stove. Ouch! Pain receptors in your skin instantly fire off a warning signal. But here's the cool part. Instead of going all the way up to the brain for a decision, that signal only travels as far as the spinal cord. And without wasting a single millisecond, the spinal cord itself issues a command right back to the muscles in your arm to contract. You actually pull your hand away before your brain has even registered the pain. And that is the whole point. The reflex arc is a shortcut. It completely bypasses the brain, because in situations of immediate danger, speed is everything. The system's #1 goal is protection and survival, and the reflex arc is just a perfect example of that beautiful, brutal efficiency. You know, when you put all these pieces together, it is just staggering. We've just taken a quick tour of the intricate biological machinery that governs our entire existence from moment to moment. Think about the sheer range of its power. Every single action, from the invisible firing of one tiny neuron all the way to the breathtaking coordination of an Olympic gymnast, it is all orchestrated by this one incredible system. And really, that's what it all comes down to. The nervous system isn't just a part of you. It is the physical machinery that creates your consciousness, your memories, your personality. It is the literal hardware that makes you, you. And that leaves us with one final thought to chew on. If this incredibly intricate system is the hardware that defines who we are, what happens when that machinery changes? Through learning or injury or even just by getting older. What does that tell us about the very nature of ourselves?